So here we are, lesson 4, if statements patterns. 6 patterns in this section are AND versus nested if, defensive guard, early return, multiple return spots, build up return, define and refine. So I've been going over this lesson without recording it, but I can just quickly go over it again. Since if statements are so useful, they can be a little overwhelming when you get started. This lesson gives you some examples of patterns that can help guide your thinking about using if statements in different ways. These patterns are not officially part of Python language. They are merely templates that we have created based on common patterns we see in code. They are not exhaustive since there are many ways to leverage and twist conditionals, but if you treat them as starting points, you may find that they inspire you in different decisions. So, AND versus nested if. An if statement nested inside of an if statement is equivalent to having both conditions combined with an AND statement. The advantage of an AND expression is usually brevity, since the code will only take up what is usually brevity. Brevity is something short. Since the code will only take up a single line without an extra indentation. The advantage of the nested if statement, however, is a little more nuanced. Statements can be added before or after the inner if statement, allowing more statements for the first case, but not necessarily for the second. You can also specify additional cases behavior by adding an elif and else statements to the inner if statements if you need to narrow the behavior further in the case where the first condition is true and the second condition is false. If A and B is the same as if A, if B. As a concrete example, observe the following code. The first version has to have redundant version of the whether.lower parenthesis check. The second version has an extra line of code because of the second if statement. Just because a program takes fewer lines of code does not mean that that solution is more readable with less redundant logic. The second block of code is less likely to have typos once you get used to reading nested if statements. If whether.low is assigned is equal to sunny and temperature is below 70, print warm. If whether.lower parenthesis is equal to sunny and temperature is below 30, print cold is the same as if whether lower parenthesis is assigned sunny, no, is equal to sunny. If temperature is greater than 70, is equal. This is equal sign, and a single equal sign means is equal. It's assigned, I mean, it's assigned. Damn, it's so confusing. If temperature is bigger than 70, print warm. If temperature is below 30, print cold. What happens when there are multiple return statements in a function? The return statement must be placed under other control structures like if statements, or the other return statements will not be reachable. Each return statement must be guarded, otherwise only the first return statement will have any effect on the flow of execution. The function ends when the first return statement is reached. A return statement ends the function in Python regardless of whether there are more lines of code after the return statement in the body. Defensive guard. There are operations and functions which are valid syntactically but will cause an error in practice. The defensive guard pattern is just a concept of protecting those operations from occurring by first checking the data involved is valid. The pattern is simple. If something, potentially useful operation. A classic example is division by zero, which causes a zero division error. Using an if statement, you can make sure that a variable such as time is greater than 0 and therefore safe to use for the denominator. Nether. Python. Guard against division by 0. If time is greater than 0, speed is assigned to distance and time. As another example, you can use the isDigits method of strings to make sure that the string is all numbers before you try to convert it to a float or integer. Guard against bad conversion. If user input isDigits, age is assigned init integer user input. One other common check is testing the length of a string before you index a specific character. If you want the first or last character, then you must determine that the string is non-empty. This can be easily done using truthiness. However, if you want a specific inner character, you must check that the string is at least that long. Truthiness to test if there are any characters. If user input last character is assigned user input -1 index -1, first character is assigned user input 0. Okay. Check length to make sure that there are at least 3 characters. If len user input is greater or equal 3, third character is assigned user input index 2. Check length to make sure that there are at least 3 characters. Okay, so the index 2 is the third character because the first one has index 0. In which of these cases might you need a defensive guard to avoid an error? Make sure that an integer is not 0 before a division. Correct, that would cause a 0 division error otherwise. To make sure that a string has only digits before you convert the string to an integer. Correct, that will cause a value error otherwise. Make sure that the string has at least 1 character before you index that first character. Correct. That would cause an index error otherwise. And not to make sure an integer is positive before you convert it to a string, because it would work anyway. Early return. Early return pattern is like the defensive guard pattern. It's like the defensive guard pattern with an if statement ending a path inside of a function before an error or other undesirable operation can occur. Okay, that's some interesting concept. So def function early return. If return, do something, return. In the following example, we check if the message parameter does not have a truth value for a string. Any non-empty string will be considered truthy. In this case, then indexing is only attempted if the message is not empty. This is very important since indexing the last character of the string will cause an index error if the empty string was indexed. The early return prevents the mistake from occurring, allowing us to safely use the logic in the rest of the function to determine what kind of punctuation symbol the last character of the string holds. Okay, so definition. Defined get punctuation is assigned a message. Like message is assigned string and type string. If not message, return empty string. Last character is assigned message -1. If last character is equal to this sign, question mark, then return question. Elif last character is assigned dot, return statement. Order, return order. Actually, okay, I get it. Multiple return spots. Parsing code with multiple returns can be a little tricky. What gets returned? The key thing to remember is that a function can only return exactly once. That will happen regardless of whether you have a return statement, but if a return statement is encountered, the function is over, and whatever value is specified in the return statement is what it brought back to the original call site. That's why having more than one return statement only makes sense when you have if statements. The if statements can disrupt the control flow of the function, branching off different paths for each return statement. For each call to the function, only one path needs to be taken, with only one return statement being activated. Define function if elif return In the following example, the convert original function consumes an integer and produces a string representation of the ordinal number such as first, second, or third. The value stored in number is matched against each of the possibilities in turn, but only one can be true since we are using a multiple exclusive chain of if, elif, else statements. Ultimately, if none of the expression evaluate to true, then the else block is entered and the value order is returned. Define convert ordinal, so number, integer, type string. If number is equal to 1, return first. Elif number is equal to, return second. Elif number is equal to 3, return third. Else return order. What happens when there are multiple return statements in a function? Each return statement must be guarded, otherwise only the first return statements will have any effect on the flow of execution. The return statements must be placed under other control structures like if statements, or the other return statements will not be reachable. The function ends when the first return statement is reached. Correct. A return statement ends the function in Python, regardless of whether there are more lines of code after the return statement and the body. Build up return patterns. Pattern. A related pattern is the build up return pattern. Build up. How is different from the multiple return spots pattern? How is this? Functionally, they are equivalent. The value being returned is meant to be the same in either pattern. The difference comes in the number of return statements and the exact path that the control flow takes through the program. Some folks try to avoid having multiple return spots in their program since it's a common source of mistakes in beginner programs. For those struggling with control flow, it can make a lot of sense to avoid trying to mix the confusing branching of if statements with the abrupt finality of return statements. The build-up return pattern can help you isolate the return to a single spot, making it easier to think about. Define function if result elif result else result return result. In the previous convert ordinal pattern, we had return statements inside of the if statements, but now there is only one return after all the conditionals. Instead, assignment statements are used. The result is still the same though. Define convert ordinal number, integer, type string. If number is equal to 1, result is assigned first. Elif number is equal to 2, result is assigned second. Elif number is equal to 3, result is assigned third. Else result is assigned order. Return result. Why might you use the build-up return pattern instead of the multiple returns pattern? The multiple returns pattern often leads to faster code. Which is multiple return? The build-up return pattern guarantees that a value will be returned no matter what, unlike the multiple returns where you might forget to return a value from a branch. The build-up return pattern only has one return statement, so the control flow is a little less complicated. The multiple returns pattern often leads to a shorter code. Okay, so I solved this. It haven't took me that long, but anyway. So the multiple return patterns often leads to a faster code, which is absolute nonsense. It's opposite. The multiple return pattern often leads to a shorter code, also nonsense. The build-up return pattern guarantees that a value will be returned no matter what, because at the end there is a return, so the computer has to go over all statements. Unlike the multiple returns where you might forget to return a value from a branch. Correct. The build-up return pattern makes it impossible to forget to provide a value, but the multiple returns make it quite easy. Of course, you should really be careful to always unit test your code so that you aren't forgetting things either way. Correct. Having multiple return statements make the control flow more confusing, since the function could end at any point. You have to keep track of which lines were skipped. The build-up return pattern only has one return statement built up. So the control flow is a little less complicated. Define and refine pattern. The else statement is a powerful way to specify default behavior after if and elif statements. But when nesting these statements, the else branch is not always conveniently available. The nested statements represent specific narrow cases involving multiple conditions. To provide a default situation with else statements, every single level of nested if would need to have an else statement, sometimes leading to redundant code. However, the define and refine pattern allows you to specify an initial value for a variable and then only specify the branches to change that value. If else value default becomes value is assigned default if following is an example that is much easier to read when the define and refine pattern is used instead of having an else statement for every if statement. By initializing a default value for whether, we avoid having else statements. Whether is assigned unpleasant. If temperature is greater than 50, if temperature is smaller than 80, if rainfall is assigned 0, if rainfall equals 0, whether is assigned nice, or equivalently. Weather is assigned unpleasant if temperature is greater than 50 and temperature is smaller than 80 and rainfall is equal 0. Weather is assigned nice. Of course, sometimes there's readability value in having an explicit else case so that future developers will understand that you meant two cases to be distinct from each other. With every one of these patterns, you must think critically about how you can make the code as readable as possible and whether the pattern improves the code or not. Okay. Summary. There are many ways to use if statements to improve readability and control your code flow. The end versus nested if pattern observes that nesting if statements is functionally equivalent to chaining together and operators. The defensive guard pattern suggests using an if statement to avoid errors. The early return pattern is like defensive guard, but specifically used inside of function definitions to terminate the function prematurely. The multiple return spots pattern explains how to structure code so that you can return a different value based on function arguments. Build-up return pattern is an alternative version of multiple return spots pattern that avoids having multiple return statements by using assignment statements instead. The define and refine pattern suggests initializing a default value for a variable instead of using repeated else statements for a complex conditional.